Okay, this is unit 11.1, notes 11.1, heat of a reaction. And let's define what that means, the heat of a reaction. The heat of reaction, delta H, which means change in heat, of the Rxn, which is an abbreviation for reaction, is the energy that is absorbed by or released when 1 mole of reaction takes place. It has a unit of kilojoules per mole. So if we think back to our example where we made water, H2 plus O2 yields H2O, where did that energy come from? The energy actually came from the bonds being formed. We're going to get to that down here in a second, but I want you to think about this because a lot of people think that the energy came from bonds being broken, and that is not true. Energy came from the bonds being formed. Energy is released when new bonds form. This is an important misconception that people often have. They think the energy is released when the bonds are broken, and that is not true. Breaking bonds requires the absorption of energy. Forming new bonds releases energy. The bond energy is the average energy required to break 1 mole of a bond, or the average energy released when 1 mole of bond is formed. Again, average energy released when 1 mole of a bond is formed. This is an important misconception here. Okay, energy is released when new bonds are formed. Example 1, consider the following for the combustion of methane, CH4. CH4 plus 2O2 yields carbon dioxide and water. Okay, so before I get into this, you can actually calculate how much energy is either absorbed or released in a chemical reaction by you looking at the number of bonds broken over on this side versus the number of bonds formed on this side. And that's what you're going to end up doing today in your worksheet. You're going to count the number of bonds broken here and compare it versus the number of bonds formed here. And if this side wins out, you're going to have heat released. If this side wins out, you're going to have heat absorbed. Okay? If you have heat released, your delta H is going to be negative. If you have heat absorbed, your delta H is going to be positive. So before we get to that, let's go ahead and draw the Lewis structures of the reactants and products. We have CH4, so let's draw this thing. CH4, if you guys will recall, looks like this. CH4. These are all carbon-hydrogen single bonds. Plus 2O2. So let's actually draw 2 O2s. O2, remember, looks like this. And here's 2 of them. Okay, 2 O2s. So CH4 plus 2 O2s yields CO2. Well, before I do that, let's look at the bonds between the O2s. These are oxygen-oxygen double bonds. And there's 2 of them there. 1, 2. Okay, here's our products. We've got carbon dioxide and 2 H2Os. Okay, well, actually before I draw that, carbon dioxide, we have an oxygen-carbon double bond. And how many of those do we have? We've got 1 here and 1 there. Okay, and now let's draw 2 H2Os. And that's an oxygen-hydrogen single bond. Okay, and how many of those do we have? 1, 2, 3, and 4. On the Lewis structures, cross out the bonds that are broken and circle the bonds that are formed in this reaction. Okay. I'm actually going to do this. I'm going to color code it. Okay, these are broken. These bonds are broken. These bonds are all broken. And these bonds are broken. What new bonds are formed? These are the new bonds that are formed right here. Oxygen-carbon double bond, because look, that didn't exist over on this side, did it? There was no oxygen-carbon double bond. That's a brand new bond that was formed. And there's two of them. The yellow indicates the bonds. And oxygen-hydrogen double bond. I'm sorry, single bonds. And there's 1, 2, 3, and 4 of those that are formed. Okay. The process of breaking bonds is, well, because it takes energy to break these bonds. You have to put energy into this system in order to break these bonds. So the process of breaking the bonds is endothermic. So the energy will be positive. You're adding energy into this system to break these bonds. The process of forming bonds, however, is exothermic. So when you hear an explosion from, or you feel heat released from a chemical reaction, that is new bonds being formed. It's exothermic. Energy will be negative. You're losing energy out of this system now. Okay, you're losing this energy because these new bonds are forming. They're releasing plus heat. Okay, it's releasing heat. So this side of your equation is actually exothermic. And if the value of the heat release is greater than the value of the heat absorption, then you have an exothermic reaction. And how do I calculate that? I look here at these bond energies, okay, and you'll be given a table like this. The total energy of the bonds broken and bonds formed using the table of bond energies. Total the energy of the bonds broken and bonds formed using the table of bond energies. Then total the energies to get the delta H of the reaction. You're going to be doing this in your worksheet today. So let's see. We break 4 carbon-hydrogen bonds up here. 4 CH single bonds. That's plus 4 times. Remember, we're adding in energy, so that's why this is positive now. Plus 4 times, let's have a look, 413 kilojoules per mole for a grand total of plus 1626 kilojoules per mole. How many of these double bonds, oxygen-oxygen double bonds, do we break? We break 2 of them. So here's how we do that. We say plus 2 times, let's see what the value of these are, 495. Okay, so my total for this is going to be plus 990 kilojoules per mole. Okay, let's do the next one. We form how many of these CO double bonds? Well, let's count them. 1, 2. So 2 of these. That means there's going to be, oh, and by the way, this is releasing energy. So we're going to change this plus now to minus. It's exothermic. It's releasing energy when these things form. Right? We said that. Energy is released when new bonds form. I said that at the very beginning, and it says it again here. So we change our sign now to minus. We've got 2 of these CO bonds, the double bonds that form, at a grand total of 745 kilojoules per mole. Okay, so our total here is going to be negative 1490 kilojoules per mole. Alright, and now let's look what else happens here. We've got, we form OH bonds, and how many? 1, 2, 3, and 4. 4 of these OH bonds form. It's on the product side. It's on the product side, so this is going to be negative now. Negative 4 times OH single bond, 467 kilojoules per mole for a grand total of negative 1868 kilojoules per mole. Okay, so now what you do is this. You've got the amount of heat needed to break these bonds, the amount of heat released when the bonds are formed, and you tally up your totals using simple addition. If you get a negative down here, then this reaction is exothermic and it releases energy. If you get a positive down here, then the reaction is endothermic and it absorbs energy. So let's tally all of these up. Well, I've actually done it. You can do this in your calculator if you'd like. And when I add all of this up, I get the grand total of negative 716 kilojoules per mole. Negative 716 kilojoules per mole. That tells me that this reaction is exothermic. It releases energy. That, in my opinion, is pretty darn neat. Okay, I'm going to go ahead and stop this video. I'll continue with part 2 coming up.